Hi, welcome back. So in the last lesson, I asked you to make a calculator similar to the one we made last time, but make a few changes to it, add a few couple of advanced features. So let's have a look at this again. I type in 5, it will tell me that 5 is an odd number. If I type in 6, it will tell me 6 is an even number. And now I have to type in a specific input if I want to get an addition. So let's say it's yes. I can say no, but if I type in anything else, it should tell me, well, I didn't understand what you said. Let's type y here. So addition is 11, you didn't ask for subtraction, and incorrect input for multiplication. So here's my code, here's how I did it. It should look similar to the one that we had before, but here are the changes I made. Here I'm checking whether a number is odd or even. I divide it by 2, get the modulus, and if the remainder is 0, then I know that this number is even. Otherwise it's going to be odd. I do the same thing for the second number. Here's where I print out that I want specific input now. And then using logic operators and comparison operators, I check whether the input matches one of the inputs that I asked for. If it matches yes, yes, or y, I say, okay, here's the addition. If it matches no, no, or n, I say you didn't ask for it. And if it's neither of these 6 inputs, then I just say incorrect input for addition because I don't know what the user is typing. I did the same for subtraction, multiplication, and division. You will find the solution in the description below, and let's move on to the lesson now. In today's lesson, we will be looking at 2 ways to store multiple values in one variable. Lists are another type of value in Python and are similar to dynamic arrays in other programming languages. A list basically consists of multiple values, all assigned to one variable. These values can be of different types. Lists are denoted in Python by different values separated by commas between square brackets. Examples include a list holding any number of integers, like just 1 and 2, or 1, 2, and 3. They could also be holding strings, like A, B, and C. Since one list can hold different types of values, a list with integer 1, string A, and a boolean true is also a valid list. A list that doesn't contain any values is called an empty list. We can assign an empty list to a variable by assigning a pair of square brackets with nothing inside to the variable. To assign a list with values to a variable, we simply write the values inside the square brackets separated by a comma. The values in a list are indexed, meaning that they have a number assigned to them. The first item on the list has the index 0, second item is index 1, and third item is index 2, and so on. To access a value in a list, we write the name of the variable that the list is assigned to, followed by square brackets, and the index of the value inside the brackets. So, to access the first value, we would write 0 inside the bracket, the second value would have the index 1, and the third value would be index 2, and so on. A list can hold another list as its value as well, similar to multi-dimensional arrays in other programming languages. To get the number of values in a list, we can use the len function. We write the variable name the list is assigned to in the parentheses of the len function. The len function returns an integer, which we can assign to another variable if needed. Let's look at how we can change, add, and remove values from a list. To change a value in a list is to simply access that index in the list and assign it a different value using the assignment operator. To add a value at the end of the list, we write the variable name that the list is assigned to, followed by a dot and then the function append. The dot signifies that we are calling the function append on the list assigned to the variable name before the dot. This is called the dot notation. We write the value we want to add inside the parentheses of the append function. To insert a value at a particular index in a list, we call the insert function on the list using the dot notation. This time, we need to provide the index and the value to be inserted to the insert function. To provide 2 values to a function, we add a comma between the values. The first value that the insert function needs is the index where the value is to be inserted, and the second value is the value itself that is to be inserted. After a value is inserted at a certain index, the values after it have their indexes increased by 1. To remove a value at a certain index, we use the pop function. Since we want to call the pop function on a certain list, we use the dot notation again. If we provide the pop function with the index of the value that we need to remove, it removes the value from that index, and every value after that index has their indexes decreased by 1. If we do not provide an index to the pop function, it simply removes the last value in the list. If we want to remove a particular value from the list, but do not know its index, we use the remove function. Using the dot notation again, we provide the remove function the value that we want removed from the list. If there are multiple values in the list, it removes the first one. If the value never appears in the list, we get an error. Now, that's it for list. Let's look at another type of value in Python. Tuples are very similar to lists in Python. However, once tuples are assigned, their values and size cannot be changed. The differences between tuples and lists are highlighted in red. The main difference in notation is that the values in the tuple are denoted inside parentheses instead of square brackets. Everything else remains the same. You can even assign a variable to an empty tuple, which doesn't have many use cases since you can't do much with an empty tuple, since the contents and size of a tuple cannot be changed. The following points don't apply to tuples. Now, let's look at a few things that can help us when working with lists and tuples. We can also get a subset of a list or a tuple. We use notation similar to when we're accessing an item. However, instead of providing just one index, we provide two indexes, separated by a colon. The first index is the starting index, and the index after the colon is the index where the subset would end. If we leave the index before the colon blank, it starts at the first index, and if we leave the index after the colon blank, it includes every value from the starting index till the end. We talked about having lists and tuples inside other lists and tuples. To access an item that is inside a list or a tuple of another list or tuple, we simply add another bracket with the index. The first bracket with the index after the variable accesses the list or tuple with the item. The second bracket then accesses the item itself in the list or tuple that we just accessed. Now, let's try coding some of these into our programs. So, first, let's how about we assign an empty list to a variable. Then we can print whatever x is holding and the type of x, obviously. Okay, we can do the same with tuples as well, but this time around we're going to use parentheses instead of square brackets. We can do the same thing again. And now it says class tuple. So let's try adding values to them as well. Let's make the tuple hold some strings. Okay, now they're holding values as well, but they're still tuples and list. We can say we want to print the first item. Print first item in X. And to print the first item, we obviously have to type in index 0 because the starting index of any list or tuple is going to be 0. So now we say the first item in X is 1, which is true as we can see. We can do the same thing for the tuple as well. Notice how I still use the square bracket notation to access an item, whereas even though tuples are denoted by parentheses, to access any item we use the square brackets. First item in Y is an A, which is also correct. If I want to change these values, say I want to set x1 to or x0 to something else. I want to set x0 to A and y of 0 to the number 1. And I can print these items again. Let's see what happens. What have I done wrong here? Support item assignment. Right, so this is the error that we're supposed to get because tuples don't allow assignment because you cannot change the value of a tuple. But let's just go with the list for now. See, now the list was 1, 2, 3. Now it is A2 and 3. And if we add that back that we had before, try changing the value of the tuple, and we get an error, just as we should. Then we can, let's see what happens if we try accessing x1 of 10. Because this means we would be accessing the 11th item in X. But as we can tell, there are only 3 items in here. Let's see what happens if we try to access this one right here. And of course we get an error. Oh, this is for the different error. Let's remove this for now. Now we get the index error, right? The list index is out of range. Like we're trying to access an item. We're trying to use an index that is out of range, that does not belong to this list right here. We can, let's see if we want to add an item to X. Instead of this, we can say x.append. We can do, let's say 10. Let's see what X is before, and then we can see. Let's remove these two things. Obviously, we can't do that to tuples because we can't add, delete, or remove items from tuples. So let's get rid of the tuple for now. Okay, let's run this. So now X was 1, 2, and 3, and then X, after I run the append function on X with the value 10, 10 also now belongs to the list. That's how you add something. We can add this a couple of times actually. And if we run it, and now there are 3 10s added to the list. We can also remove the last item. Let's say x.pop. We do this, and there we go. And now the last 10 is removed. Let's put this here, and then press print x again. So we want to see what happens after we have added these values. Let's call this 11. Let's call this 12. And as you can see, pop removes the last item in the list. It doesn't remove anything else, just the last item in the list. If you want to remove something from a certain point, we'll have to use the remove. If you want to remove, say for example 10, right? We want to remove 10 from this list. We can say x.remove 10. And now 10 is removed from the list, whereas 11 and 12 are still in the list. So that's the differentiation between pop and remove. In pop, we can either not give it an index, and it will just remove the last value, right? Last value. And if we do give it an index, say I want to remove this one, the index of this number right here is going to be 1. So let's say I say 1 now. Now I expect it to remove 2 from the list, which it just did. And if you want to remove a number, not an index, but use the number itself, 10 or 2, let's say, let's try to remove the same thing. So we should get the exact same thing again. But this time around, we're using the number 2, not the index. We're going to have to change this to remove. Try it again, and voila, we get the exact same thing, but using a different function and using the value itself. Now, we can set values to something else too. Let's say I want to set this to 3. Now this will change the value of 0, 1, 2. So this is already 3. That won't do anything. Let's change it to 5. So before X was 1, 2, and 3, then we add 3 numbers to it, and then I change the third item to 5. So now it is X, 1, 2, 3, and 5. Now we talked about having, lists within a list. Let's look at that too. Let's say the third item itself is a list, right? So now I want to access, let's give them different things, just so we can distinguish them. So let's say I want to access B now. How would I go about accessing B? First, I have to access this item in the list. This item has what index? This is index 0, index 1, and this whole thing has the index 2. So if I print out index 2 right now, it will just, let's remove everything else so we know exactly what we're looking at. Okay, now index 2 is A, B, and C. Now this is just another list. To access a list, an item in a list, we just add square brackets to it, right? Let's say I want to access B, and the index of B is what? 0 and 1. We type in 1 here, and now I should get B, just B. That's how you access items that are the items in a list that are inside a list. Now this can keep going. Obviously, this third item could yet be another list, right? If I don't have too many, yeah, this is fine. And then this can be, I don't know, 4, 5, and 6. Now I want to access 5. So first I will access this index right here. That's 0, 1, 2. Let's go step by step again. So this will get me this, right? Now I want to get 0, 1, 2, the third item now. So that's going to be 2 again, 0, 1, 2, right? And that gets me this list. Now to get 5 out of this list, I'll have to use the index 0 and 1. Type in 1 again, and now I should get 5. So that's how you work with when you have multiple lists or tuples inside other lists and tuples. This would work the exact same way if it was a tuple. I could even just change this to a tuple, and I won't have to change anything else, and I would still get 5 because you access items in a tuple the same way you access items in a list. We also talked about getting subsets of items in a list. So let's say I have a list with these numbers, and I want to get these 3. So I would give the first number, the index of the first number, so 0, 1, 2. So that will be 0, 1, 2, right? Because this is what I want. I want 3, 4, and 5. This is all I want. So I would give the index of the first number, which is 1, 2, and then the colon, and then I give the index after the last digit. So if I want up till 5, I'll have to give this index right here. That's the index of this number. So if I want 3, 4, and 5, I give the index of 6, which is 0, 1, 2, 3, 4, 5. So let's type in 5, and let's see what happens. And I get as expected. Now this 2 is a list, by the way. Let's see the type of what this is. This is a list as well. If it was a tuple, I would just get a tuple, right? Oh, this thing right here, because I'm trying to add values to it. If I do this, I once again get the subset of a tuple right here, right? So that makes sense. Now, that's it for this coding lesson. Let's have a look at the problem now. So, the problem for this lesson, I want you to, we're basically designing a wage calculator where, say the employer wants to type in the employees and their details in the computer, in the program, and then the program will calculate how much each employee has made. So first, let's say the program is going to ask by asking a few details about the employees. It's going to ask to enter the name. Let's say we type in my name, and then let's say I make $14 an hour, and then hours worked, let's say 20 hours. Now here it's going to show the record of how it is storing everything in the background. It's going to store the name, the wage per hour, and the hours worked in a tuple, in one tuple, and that tuple is going to be part of a list. Now if we do the same for the second employee, let's say 15, and let's say this person worked 35 hours. Now this is the second record right here. This is also stored as a tuple. Now we're storing them as a tuple because these will not change once we have assigned them. So to stop us from changing them on accident or someone else, we just use them as tuples. Let's type in one more person. Let's say this person's the manager, is making $25 an hour, and they work 40 hours a week. So now these are all the records that it needs. For now, we're going to stick to only 3 employees because that's all we want to work with. Then it's going to ask you to tell you the name of the employee. Let's say I type in John. Now it's going to tell me that John earned $1,000. It's just going to multiply the wage per hour and then the hours they worked, and then tell me John earned $1,000. So for this problem, I want you to stick to just 3 employees, ask for the name, the wage per hour, hours worked, store all of that as a tuple inside a list, and then at the end, ask for the name of the employee and go through the first item in each tuple and check if it matches any one of them. And if it does, just multiply the wage per hour and the hours worked by each other of that particular employee and just say how much that person earned. If it's not there, then just say invalid employee or something like that. That's it for this problem. I will show you my solution in the next lesson, and I'll see you then.